Hi, everyone. So we are going to go over our quiz 6 today. Let's jump into our first question. We were asked to give a restriction on the domain of y is equal to sine x that would make it a one-to-one function and would include that first quadrant. So um, there's more than one possible solution in here. Our famous domain restriction for our sine of x is good old negative pi over 2 to pi over 2. One-to-one functions, what does that mean? It needs to pass our horizontal line test. And so if you had negative pi over 2 to pi over 2, that would suffice as one of the solutions. And then you're done. Let's move on to our question 2. We're asked to find the exact value of cosine inverse sine of negative 11 pi over 4. So let's really hone in on what I'm highlighting in orange here. And that negative 11 pi over 4, let's really take a look at that visually on our unit circle. As a mixed fraction, negative 11 pi over 4 is negative 2. 4 times 2 gives you 8. And then 11 minus 8 gives you 3. So we have negative 2 and 3/4 pi. So that we can really see where this angle lies, which quadrant it lies in, to identify um, where it's going to be, what's the value going to be, and is it going to spit out a negative result or not. So uh, we know that negative, we're going into the clockwise rotation, and one full revolution gives us 2 pi. So we're here for that negative 2 pi. And then we're going down another negative 3/4 pi. So 1/4 pi, another fourth pi, and then another fourth. So in quadrant 3 lies our negative 11 pi over 4. And I'll show you how many rotations were done in order to get that to that level. So we had one full rotation and then a 3/4. And there we have it. Okay. We want to find sine of negative 11 pi over 4. So what is the reference angle of that? That's just pi over 4, but we're in that third quadrant, which tells us that when we're dealing with sine, sine is going to be negative there. So we can rewrite this sine of negative 11 pi over 4 as negative sine of pi over 4. And we know pi over 4 is just square root of 2 over 2. So we just get negative square root of 2 over 2. Now we're going to bring down that cosine inverse because we want to now ask ourselves, cosine of what angle, cosine of theta, will give us negative square root 2 over 2. And maybe I'll draw another little unit circle here so it doesn't crowd the other one. But again, we really want to highlight now our acronym All Students Take Calculus so that we can hone in on the quadrants that make cosine negative. So that is our second quadrant and our third quadrant. So cosine of what angle gives us negative square root of 2 over 2? Well, we know we're dealing with some reference angle of 45, but more specifically, that reference angle that represents 45 in both your second and your third quadrants. And so this gives us 3 pi over 4 and 5 pi over 4 as your solutions. However, it says find the exact value, and we have no bounds here. So we need to generalize this. We have all possibilities of 3 pi over 4, aka think terminal angle, so plus or minus 2 pi k, where k is an element of our integers. And we have all possibilities of 5 pi over 4. So we have 5 pi over 4 plus or minus 2 pi k, where k is an element of our integers. And we're done. These are our 2 solutions. Maybe I'll shrink this, see if I could put it all on. Okay. Let's go ahead and move on to our question 3, where we're asked to use the fundamental identities to simplify this expression. Cosecant x is the same as 1 over sine x. Cosine of x as a fraction is just cosine of x over 1. Cotangent of negative x, well, what do we know about cotangent? Cotangent is an odd function, so we can actually rewrite cotangent of negative x as negative cotangent of x. And we know that if tangent is sine over cosine, cotangent is just the reciprocal, so cosine over sine. So we are going to multiply this cosine x as, I'll write it down here too, negative cosine of x over sine x. And we're done with the first row. Still a little early this morning. So now what do we want to do? Let's go ahead and simplify the yellow and the pink by just taking the product. So we're looking at cosine x times negative cosine x gives you a negative cosine squared x all over sine x. And then we can bring down that 1 over sine x. So now, since the denominators are exactly the same, this minus can go there so it looks a little cleaner. We can all put it under 1 fraction. So we end up with 1 minus cosine squared x over sine x. Pythagorean identity is finally displayed in that numerator. We know sine squared x plus cosine squared x equals 1. So if we subtract that cosine squared x from both sides, we end up with sine squared x is equal to 1 minus cosine squared x. And so we can replace that. And when we do, we get sine squared x over sine x, which is really just sine of x in fully simplified form. And And that completes this problem. Oops. Finally, let's move on to our question 4, which has 3 different parts to it. Gonna try and fix that. Give me a 3 different parts. We're going to be testing our knowledge of sum and difference, double angle, and our half angle formulas. In this first case, we have the pairings are the same, which means we're dealing with some form of cosine, and cosine's properties are the signs are opposite. So we're essentially dealing with cosine of alpha minus beta. And so our alpha here is this 3 pi over 7. Our beta is 2 pi over 21. So we're just looking at cosine of 3 pi over 7 minus 2 pi over 21. So we're just essentially subtracting fractions from one another. How do we do that? Get a common denominator. So we're looking at 9 pi minus 2 pi all over 21, which is just 7 pi over 21. And 7 pi over 21 can be simplified to just pi over 3. And what is cosine pi over 3, aka cosine of 60 degrees? That just gives us 1/2 to be our final result. Let's move on to part B, where we're dealing with a double angle formula here, specifically our sine double angle. So sine of 2x is equal to 2 sine x cosine x. So what we're going to do here is we are going to let that 3 theta be equal to our x. So let x equal to 3 theta, which means that 2x is just 2 times 3 theta, which gives you 6 theta. And now we're just going to substitute in. So we get our final answer to be just sine of 6 theta. Last but not least, we have our part C, which deals with our knowledge of half angle formula, and more specifically, our sine half angle formula. So our general formula is just sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha all over 2. And so if our alpha here, we'll use red, is pi over 8, our alpha over 2 is pi over 8, then our alpha is double that, which makes pi over 4. And pi over 4 lies in our first quadrant, so we have positive, therefore the positive sign. All trig functions are positive in that first quadrant. And now we just want to substitute in. So we get our positive version of 1 minus cosine alpha, which is just cosine of pi over 4, all over 2. Pi over 4, whether we're dealing with sine or cosine, is our square root of 2 over 2. So we have 1 minus square root of 2 over 2 all over 2. And then let's get a common denominator here. In that numerator, we can multiply that 1 by 2 over 2. So we can put that numerator all in terms of one fraction. And we get the square root of 2 minus square root of 2 all over 2, all divided by 2. So we're going to utilize a little keep change flip because 2 as a fraction is 2 over 1. And so when we keep change flip, we get positive the square root of 2 minus square root of 2 all over 4. And last but not least, we can take the square root of 4. That just gives us 2. So our final simplified version is positive square root of 2 minus square root of 2 all over 2. And that completes this question along with completing quiz 6. I'll zoom out so you can really see it. And then I can actually zoom out for the entirety of the page. I hope this was helpful. Let me know if you have any questions, and I will see you for the next video. Take care.